here is here are two more solutions for two more Taylor series questions. They were both number 6. No surprise there. All right, make some room here. Get this all set up how I want, and we'll get into it. All right, that looks good. Okay, so here's my series here. If you know your series, the ones that you're supposed to be familiar with, this one, you might recognize that this is pretty close to the tangent inverse series. It's not quite, but whatever. You might notice that it's alternating. And you might notice that it's only odd terms. You might notice that they're not factorials on the bottom, which it means it's not going to converge everywhere. So that's just some observations there. So using the ratio test, determine the interval of convergence of the series. Okay, so ratio test. I know they said to use the ratio test, but I'm just going to write it anyway. Ratio test. To do the ratio test, we find the limit as n approaches infinity of the n plus 1 term. So that would be this, and I'm ignoring the sign flippers, right? I'm not going to put that in. So I'm going to put n plus 1 in there. That would make that x to the 2n plus 3, right? Because I'm putting the n plus 1 in there. And then this would be 2n plus 5. Right, because I'm putting n plus 1 in there. And then I divide by the n term, which is the same as multiplying by this reciprocal. Okay, so I'm going to write out, I don't know, maybe one more step than what I would normally write out if I was just doing this as a homework problem or something. I'm going to, so this is x to the 2n plus 3, x to the 2n plus 1. There's 2 more x's up here, so that's an x squared. And then here, this is 2n plus 3 over 2n plus 5. Highest power top and bottom is 1 and 1. Ratio of the coefficients is going to give me 1. So that's just equal to x squared. And then the ratio test is that right there has to be in between whatever you get here has to be sandwiched in between -1 and 1, right? So that just means x values between -1 and 1. So this is the interval of convergence. And now I have to check the endpoints. If you got, this is probably, I haven't looked at the scoring guide for this one recently, but this is probably worth 5 points right here, this part A. And if you get as far as this, you're probably going to get 3 of them. But checking the endpoints and then having the right actual thing on the end with where the equal signs are, that's going to be the last 2 points, I think. Would be my guess. Okay, so the endpoints are, first I'm going to check x equals -1. And the way I check the endpoints, I just write out the first 3 terms and then see what I got. So here, that's going to be -1/3, and then well, let's see. So if I plug in the negative here, that's going to be negative, and then another negative sign. So that's going to be actually +1/5. Have to be very careful. It all comes down to what these signs are very often. And this converges. You don't have to go into a whole lot of detail about whether or like what the argument is. This converges because it's an alternating series and the terms are going to 0. Alternates and the terms going to 0. you just have to have the right answer and show that you have checked. And it looks like this is going to alternate too, right? When I plug in 1, then I just get series, so the negative 1 just flipped all the signs, so this also converges, because it's an alternating series and the terms are going to 0. If they were not alternating, they would not converge, because they would be like a p series with a p of 1 by limit comparison. It would be basically a version, an odd number version of the harmonic series. So the interval of convergence is from -1 to 1. And that's my final answer. Okay. B, the Maclaurin series for G. Remember, Maclaurin series just means Taylor series at x equals 0. You could also say the Taylor series centered at x equals 0. For G, evaluated at x equals 1/2 as an alternating series whose terms decrease in absolute value to 0. Why are they saying this? They're saying this because they don't have enough points to give out in the 3 parts of this problem to assign points to you saying that. So they're telling us that it's alternating and the terms are decreasing, so that means it does converge. So even if you messed this part up and you didn't realize that 1/2 is in the interval of convergence, they're telling you this so that you don't have to say anything about that. So the approximation for G 1/2 using the first 2 non-zero terms of this series is 17/120. Show that this approximation differs. Okay, so we're going to use the alternating series error bound. And what they're doing here is, like, we don't have to recognize, we don't have to figure out that the so-called hypothesis of the alternating series error bound has been met. We don't have to say that since it's an alternating series whose terms decrease in absolute value to 0, we can use the alternating series error bound. They said that already. Normally you would have to say that. So here alternating series error bound says that the actual value of the function, which is g of 1/2, minus the approximation using the first 2 non-zero terms, which is, I mean, there's lots of different ways you could write that out, but I'm just going to write it out. The approximation using the first 2 non-zero terms is just 1/2 over 3 minus 1/2 to the third over 5. Now, what's that equal to? Well, it's 17/120. They told us, but I'm just doing that. You could also just write the 17/120 there, whatever. So alternating series error bound says the difference between the actual thing and the approximation is not more than the absolute value of the next term. Which is this. Right? And we want to show that it's less than 1/200. So you could actually do this, and that's correct because you don't have to simplify things. I think for my own sanity, I would want to actually do the math here and make sure that that's true. So 2 to the 5th is 32 times 7 is that what? 32 times 7, 224? Is that right? So I think that's right. Right? So we did it. All right. C. Write the first 3 non-zero terms and the general term of the Maclaurin series for G prime. Okay, so just need to take derivatives of these, right? That should be pretty easy. So that's 1/3 is the first term. The next one is 3 times x squared over 5 plus 5 times x to the fourth over 7. And then the general term is, if you think about what happens here when I take those derivatives, it's going to be negative 1 to the n. They're still going to alternate. This is now x to the 2n, right? Because the power went down 1 when I took the derivative. And then I multiplied out in front. Oops, I didn't leave room for that. I guess I'll have to put it at the back here. Of course, multiplication is commutative, so put it wherever you want. 2n plus 1. That's that like 3, 5 that I was putting out in front here. And then dividing by the same 2n plus 3. Right? The numbers on the bottom I left alone. So I intentionally did it in this sort of like non-simplified way because it's easier to see what the numbers are, I think. Maybe you think it's easy anyway, but that's it. All right, so that's that one. And another one. Function f has derivatives of all orders at x equals 0. That just means you can make a series. It's differentiable forever. Let p sub n be the nth degree Taylor polynomial. So p sub 1 would be like the tangent line, p sub 2 would be the tangent parabola, and so on and so on. Okay, part A. It's known that f of 0 is equal to negative 4 and that p sub 1 of 1/2, that's the tangent line, equals negative 3. And show that f prime of 0 equals 2. Okay, so p sub 1 is equal to, that's a tangent line, right? So if you think about p sub 1 as like the y value, like that's the name of the f of x, then in point slope form that would be p sub 1 or let's not do it in point slope form, let's make it like as a little series. So then that's going to be f of 0, I was going to put minus f of 0 on this side, plus f prime of 0 times x minus 0. You could just write an x there, but I'm just kind of emphasizing the form of this. Right? So that's what that first degree Taylor polynomial looks like this, or you could just write it without the 0 there. So p sub 1 of 1/2 is equal to negative 3. F of 0 is equal to negative 4. F prime of 0 is I don't know what. And x is x is 1/2, right? Plug it in 1/2. Right? So, adding that over to there, times 1/2, and then multiply by 2, so f prime of 0 is equal to 2. Check. That's a funky little thing to do. It's like a weird thing to be missing, so fine, we can do that. And now we know the first derivative and the second derivative and the third derivative, so we can write that third degree. So the third degree, P3, I'm going to write out the general form of it first. F of 0 plus f prime of 0 times x to the first over 1 factorial plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial. That's the third degree. Right? I don't know why, but number one mistake is to forget to divide by those factorials. That's what I've seen students do a lot. So that's negative 4 plus f prime of 0 is 2 times x plus f double prime is negative 2/3 over 2 factorial times x squared plus 1/3 over 3 factorial times x cubed. You want to simplify that? Go ahead. Why would you bother though? And then part C. The function h has first derivative given by this. I'm just going to write that down. And it is known that h of 0 is 7. Find the third degree Taylor polynomial for h about x equals 0. Okay, well, how do you do that? If I want to get back to h from h prime, then I need to take the antiderivative. So that means that h of x is equal to the antiderivative of this. And I'm going to have to deal with the plus c thing over here, right? Because I know that I know that h of 0 is equal to 7. So that will be easy enough. That'll just be my first term, right? Just like the negative 4 was. Okay, so that's the integral of f of 2x. So that means I need to plug 2x into these things to get up to the third degree. So that's going to be negative 4 plus 2 times 2x. And then I guess I'm going to simplify this now. 2 in there, so that's minus 1/3 x squared. But I'm plugging a 2x in there. That's 4x squared. I think that that's right. Yeah. I like that. Apologies if I made any mistakes with the algebra. Why did I stop there and not go for this one? Because I know I'm taking the antiderivative of this, and they wanted the third degree Taylor polynomial, so that's going to get me the third degree, right? I don't actually have to deal with this one. That would get me up to fourth degree. So that is negative 4x plus 2x squared. That's the antiderivative of that. And antiderivative of this is minus 4/9 x cubed, I think. I know how to do calculus. Yeah, that looks good. And then plus c. But the c is, I know that when I plug in 0, I get 7. So that just gives me the first, that constant term. So 7 minus 4x plus 2x squared minus 4/9 x cubed. Boom.